Alright guys, so today we're going to take a look at section 5.6 on writing equations in slope-intercept form. Now, one of the biggest things about this lesson is being able to isolate y, and I'll show you the reasoning behind that in a few minutes. But for our warm-up, let's go ahead and just do a quick review of section 2.5. So if you recall, section 2.5 dealt with solving literal equations where we had multiple variables on both sides and we were able to isolate whatever we wanted to. In this section, let's go ahead and practice what we did back in section 2.5, back in, probably late September. Subtract 2x from both sides, and we're left with y equals negative 2x plus 10. Now, some of you might be thinking, well, could I write it as y equals 10 minus 2x? Back in section 2.5, that was fine, but take my word for it, it's now going to be a lot better for us if we write it like this. Number 2. Go ahead and subtract 10x from both sides. You're left with negative 5y equals negative 10x plus 15. Now, here was the case where we needed to decide, do we want to divide the entire thing by 5 or negative 5, or do we want to divide each individual one? And remember, because this negative 10 and 15 are both divisible from 5, we want to go through and divide negative 5 individually, and now we are going to be left with y equals 2x minus 3. And take a look at number 3. We go ahead and add 6x to both sides. We're going to be left with 2y equals 6x plus 12. And once again, we're going to want to go ahead and divide through individually. And once again, you'll see the reasoning behind that when we get into what the slope-intercept form actually means, and we're left with y equals 3x plus 6. So hopefully that was a quick review of section 2.5, and you are able to accomplish that main part of the lesson. Now let's do a quick kickoff here, and let's go ahead and rearrange some of these to solve for y once again. So once again, I'll do the first 3 with you, and then I'll let you try the last 2 on your own here. So for number 1, we're going to go ahead and subtract 2x from both sides, and we'll be left with y equals negative 2x plus 10. Number 2, we're going to subtract 10x from both sides. Hopefully this is like a walk in the park for you at this stage of the game. Divide through by 5, and you're left with y equals negative 2x plus 3. And for that last one, number 3, that is a negative 1/2 x plus y. So let's add 1/2 x. And you're left with y equals 1/2 x plus 13. Okay, so why don't you go ahead right now on your own, try these 2 problems right here. And I went ahead and did them for you. So hopefully you pause the video so you can see. Once again, just to save some time here, we have adding 4x to both sides, dividing by 2, subtracting 2x from both sides, and then dividing by negative 1. You can also approach number 5 a different way if you want to challenge yourself a little bit. If you have negative y plus 2x equals 5, think about adding y to both sides as a move. And that'll leave you with 2x equals y plus 5, and then you could go ahead and subtract 5 from both sides. And if you notice, you have 2x minus 5 equals y, which is exactly what we were left with in the first place. All right, so hopefully we're good to go. Now let's take a look at the main concept of section 5.6. So the main target for today is I can write an equation in slope-intercept form. Now, what is slope-intercept form? Well, we'll get to that in a minute. First of all, let's go over a little bit of review from what we did earlier in chapter 5, was just graphing lines. So we have a y-intercept. We know our y-intercept is where it crosses the y-axis. And keep in mind, the x value whenever you're on the y-axis is always going to be 0. So we have 0, negative 3. My slope is 2/3, so that means a rise of 2 and a run of 3. Both of those are positive, or keep in mind, you could always look at it as both of them are negative. Rise 2, run 3, rise 2, run 3. Do that a few times, and then let's move the opposite direction, and take a look at how quickly we were able to graph a line, and we're going to come up with that equation shortly. But this, goes back to T-charts, what we did back in chapters 1 and chapter 2. This is going to make your life a lot easier. T-charts are going to be a thing of the past if we're able to write something in slope-intercept form. Take a look at number 2. We have a y-intercept of 4, so that's 0, 4. We have a slope of -1/2. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. Or, because this is negative right here, that means that we either have -1 over 2, we have 1 over -2, or the way we wrote it from the get-go with the big fat negative sign out front, I can go up 1 and to the left, up 1 and to the left, and so on. And then just like that, my line is completed. So that right there is a quick warm-up as to graphing them. So not only writing an equation in slope-intercept form, but being able to graph an equation in slope-intercept form as well. So let's now take a look at what the actual slope-intercept form is. Slope-intercept form, and this is pretty much the Cadillac of all equations that you're going to do this year. I would venture to say there's not one more important than that. Y equals mx plus b. Now, the two main parts of this equation are the m, which represents the slope of the line, or the rate of change, and the b, which represents the y-intercept, or what we also would call the starting value. You'll do that a lot whenever we get into more word problems later on down the road. Now, we always get the question as to what do the y and the x represent? That's a great question because a lot of kids actually don't realize what they represent. Keep in mind that y and x are changing throughout the entire problem. So your goal is to be able to write an equation in slope-intercept form and then be able to plug in anything you want for x and have it spit out a value for y. Or anything you plug in for y, have it spit out a value for x. So let's take a look at how to write an equation in slope-intercept form. It's pretty much as easy as plug and chug that we've been doing all year. Classic substitution. Here's an m equaling 5. We're going to airmail that in. And here is a y-intercept of 2. We're going to airmail that in for b. And I'm simply going to rewrite my equation as y equals 5x plus 2. Now, that is as easy as it gets in section 5.6, but we actually have a lot of important information if I'm given this equation right here, because now I'm going to be able to take a look at this and identify, if I just gave you this, what my slope was right here, what my y-intercept was, so we could work backward as well. Those are our two goals. Take a look at number 4. Same thing. I'm going to go ahead and write my equation as y equals -1/2 x, and my y-intercept is -7. If you want to do the whole plus and negative thing, you can. I think at this stage of the game, a lot of you may have grown out of that, but if you still like to do it, go for it. And we have our equation of y equals -1/2 x minus 7. Now, what we're then going to be able to do with this, if you're wondering where we're heading, is I can now take my y-intercept, I can take my slope, and then I can go ahead and create a graph of it based on what we just did in this previous slide right here. So that's where we are heading once we are given an equation of a line like this. Now, let's do a quick challenge. Whenever you're given a slope and a point, this is actually a segue into section 5.7 on writing equations of lines given 2 random points or 1 random point and a slope. The part that's tricky about this is we're given m, which is beautiful. However, we are not given what? Exactly. We are not given b. So we got to go out and find a b, because remember, our equation is y equals mx plus b. So the good news is I have 3 numbers here, and I have 4 variables here. So I'm missing one of the variables, which we know is b. So I'm going to take my x value, I'm going to take my y value, and I'm going to go ahead and plug it in. So if you're thinking about what's going to happen, I'm going to say -1 equals 8 times 3 plus b. And like I said, this is definitely leading into what we're going to do in the next section, but I think it's good practice to see if you can make sense of this, because it'll definitely make the rest of the section a little easier. Once I get that, I just do some basic equation solving, and I see that b equals negative 25. Now, somebody tell me, how do I go ahead and write an equation of a line now? Well, as we saw in the last couple slides, I have an m, I have a b. All I need to do is go ahead and replace them in here, and my equation would be y equals 8x minus 25. Okay? Any questions? No? Good. Excellent. Let's take a look now at being able to write an equation in slope-intercept form and then go ahead and graph that line. Now, here's the main perk of slope-intercept, because you're able to be given a y-intercept and a b. So I can take a look right here. Here's my m value, 2, or 2 over 1. And here is my y-intercept of negative 4. So what I can now do, because it's already isolated, I simply go down to negative 4, and I rise, run, 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. And most math teachers would like you to show that you can do rise, run in both directions. So this is actually the same thing as negative 2 over negative 1. So I can go this way as well, and then I can create my line. Very nice. So go ahead and try number 7 now. Let me go ahead try it this way. 2x plus y equals 1. So go ahead and isolate y, and then go ahead and label m, label b, and then go ahead and create your graph. So take a few minutes. Go ahead and try that. I went ahead and did this for you, and if you notice, I subtracted 2x from both sides. Subtract 2x, subtract 2x. Y equals negative 2x plus 1. My slope is negative 2. My y-intercept is 1, so I went up to 1 on my y-axis. I rise 2, run positive 1. Rise negative 2, run positive 1. Rise negative 2, run positive 1. Or rise positive 2, run negative 1, and so on. All right? Now, let's take a look at a couple different kind of scenarios. You got to kind of think a little bit about what these actually represent. So in a problem like this is kind of like saying y equals 0x minus 2, if you want to think about it that way. That means your slope is 0 and your y-intercept is negative 2. Well, if your y-intercept is negative 2 and you have a slope of 0 over 1, that means you're rising 0 and running 1 for everything, which is going to make this into a horizontal line because my y value is staying constant. So that's an example of one that you can look at whenever you have just the y value with not no slope, but a slope of 0. Now over here in number 9, what might help some of you out is by putting a plus 0 in there. So let's take your y-intercept of 0. Let's go down 2, run 3, go down 2, run 3, and so on. And then draw your line this way. Notice the direction the line is sloping. We have a top left down to bottom right. This is an example of a negative slope because of that slope right there. So we have a slope of negative 2/3. We have a y-intercept of 0. Now, last question on here is the word problem, where we have to create an equation based on the problem. It says to rent a van, a moving company charges $30 plus 50 cents per mile. The cost as a function of the number of miles driven is shown in the graph. So looking at this graph, we could actually see the y-intercept at 30. So I can go ahead and identify my y-intercept of 30. Now, if you can't see that your rate is 50 cents per mile, you could always look at the graph. Go from here, rise up, and run over. Well, this is rising 10 units and running 20 units. So that's 1/2. That's where the 50 cents comes from. So my slope is actually 0.5, or 1/2. Now, let's go ahead and write the equation of the line back. So I kind of worked backward here, but I think this part should probably be for letter A. Let's go ahead and write my equation now, and we could say y equals 1/2 x plus 30. Always better to use it as a fraction instead of a decimal so that you can identify rise over run. Once you get to that part, we're going to now find the cost of the van for 150 miles. We're going to say that x equals 150. Take this, plug it in for x. Y equals 1/2 times 150 plus 30. Y equals 75 plus 30. and your final answer, y equals 105 miles.